Okay, lesson 76 is 3 equations and 3 unknowns. So we're usually going to use both substitution and elimination when we do this. Part of it we'll do substitution and part of it we'll do elimination. So let's take a look at what we want to do here. We've got x equals 2y, x plus y plus z equals 9, and x minus 3y minus 2z equals negative 8. And I just labeled the equations A, B, and C just so it's easier to talk about them. So the first thing we're going to do is substitute 2y for x in equations B and C. So equation B, we're going to have 2y plus z equals 9. And for equation C, now we're going to put in 2y for x, so 2y minus 3y minus 2z equals negative 8. And so now we have 2 new equations, and we need to add the like terms. Okay, so I'm going to rewrite B as 3y plus z equals 9. And equation C, I'm going to rewrite as negative y minus 2z equals negative 8. All right, so now I have these 2 equations in 2 unknowns, and solving this will be just like we have always done when we've solved a system of linear equations. 2 equations, 2 unknowns, we can solve it however we want to. So there's several things I could do here, but what I'm going to do is multiply equation B by 2 in order to cancel the z's. So I'm going to multiply this equation by 2, and that's going to give me 6y plus 2z is equal to 18. And this equation is not going to change. It's negative y minus 2z equals negative 8. So when I add the 2 equations together, the z's are going to cancel, and I'll just have 5y is equal to 10, and therefore y is going to equal 2. So I'm going to take that y and plug it into equation A so I can get x. We know that x is equal to 2 times y, and y is 2, so that gives me that x is 4. So I have x is 4. Now I have x and y, and I'm going to plug those into equation B to figure out what z is. So x is 4 plus y is 2 plus z is 9. So z is equal to 9 minus 6, which is 3. And I'm going to write my answer as a coordinate triple. It looks just like a coordinate pair, except it has 3 coordinates. And the first one is going to be 4 for x, 2 for y, and 3 for z. So that would be how I would write my answer. Okay, here's another one. We're going to use substitution and elimination. So in the equation that has only 2 unknowns, we're going to use that to do the substitution. So I'm going to solve for x in equation C. And now I can use that to plug into the first 2 equations. So I'm going to plug 3z in for x in equations A and B. So equation A, I'm going to have 2 times x, which is 3z, plus 2y minus z is equal to 12. And then in equation B, I'm going to have 3x, which is 3z, minus y plus 2z is equal to 21. So now I will add my like terms. So here I've got 6z plus 2y minus z equals 12. And here I have 9z minus y plus 2z equals 21. And so this is going to be 5z plus 2y equals 12. And this is going to be 11z minus y equals 21. So I'm going to use those 2 equations, and I'm going to use elimination, because if I multiply the second equation by 2, I will be able to cancel the y's. And I'm going to have 5z plus 2y equals 12. And then I'm multiplying that second equation by 2, so I'm going to have 22z minus 2y is equal to 42. And now I can add the 2 equations together and eliminate the y's. So I'm going to have 27z is equal to 54. And so z is going to equal 2. And now I can just substitute that into the equations I have to find the other letters. I know that x equals 3z. So x is going to equal 3 times 2, which is 6. And then I can plug those two things, z equals 2 and x equals 6, into either one of the other equations. I'll plug them into the first equation. So 2 times 6 plus 2y minus 2 is equal to 12. So that's 2y is equal to 12 minus 10, which is 2, so y equals 1. And now I'm going to write my coordinate triple, which is going to be 6, 1, 2. Okay, lesson 77 is radical equations. When we raise both sides of an equation to the same power, the solutions of the new equation will include the solutions of the original equation. However, there may be solutions of the new equation that are not solutions of the original equation. So we must always check our solutions when we raise both sides of an equation to the same power. This is very important. This is not just checking to see if you did the problem correctly. This is checking to see if the solution you got actually works in the original equation, because sometimes it won't. This only is going to happen when you square both sides of an equation or cube both sides of an equation, something like that. So that's when you have to check your answer. But you have to be wise about it, because if you check your answer and it doesn't work, it may mean that you did the problem incorrectly and you need to go back and fix it. Or it may mean that there are no solutions to the equation because the answer you got works in the equation you got after you squared both sides, but it doesn't work in the original equation before you squared both sides, and that can happen. So we've done it. We're going to solve this equation. So we have a cube root this time, and before we can do anything, we need to isolate the cube root completely by itself. So cube root of x cubed plus 6x squared minus 4 is equal to x plus 2. So we got it all by itself. Now we are going to cube both sides. So cubing it and cubing it. So the left side, the cube root cancels out, and we're just left with x cubed plus 6x squared minus 4. On the right side, be very careful, because this is not x cubed plus 2 cubed. It is not. It is x plus 2 times x plus 2 times x plus 2. So you have to multiply this all the way out. So x cubed plus 6x squared minus 4 is equal to, I'm going to multiply these two first. So I'll have x plus 2 here, and then over here I'm going to have x squared plus 2x plus 2x plus 4. So that is going to be x plus 2 times x squared plus 4x plus 4. And now I have to multiply this by all those things and that and that. Got to do all that multiplication. So let's go ahead and do that. I'm going to move over a little bit. So x times x squared is x cubed. X times 4x is 4x squared. X times 4 is 4x. 2 times x squared is 2x squared. 2 times 4x is 8x. And 2 times 4 is 8. So that's the right side of your equation. The left side of your equation still looks like this. And now you see you can cancel the x cubed. You've got 4x squared and 2x squared on the right side of the equation, and you have 6x squared on the left side, so you can cancel those because that's the same. All right, you've got a negative 4 on the left side, so we'll go ahead and add our like terms on the right side. So negative 4 is equal to 12x plus 8, and if you subtract 8 on both sides, you're going to get negative 12 is equal to 12x, which means that x is negative 1. So this is the answer we get for negative 1, but we can't just say, okay, let's go on our merry way. We have to check it. We have to make sure that that actually works in the original equation, which is this equation, before we ever squared both sides. So let's plug in negative 1 and see if it works. So cube root of negative 1 cubed plus 6 times negative 1 squared minus 4. Then outside the cube root, we have minus negative 1 and minus 2, and that's all supposed to equal 0. So under the cube root, we have negative 1 plus 6 minus 4, and over here we have plus 1 minus 2, so minus 1. is equal to 0. So that's the cube root of 1 minus 1 equals 0. And that is true. The cube root of 1 is 1 because 1 times 1 times 1 is 1. So this equation says 1 minus 1 is 0, and that is true. So this is the solution of this equation. Okay, sometimes you will have radical equations where there are 2 radicals in the equation. And that means that you're going to have to square both sides twice. So here we go. First of all, you have to isolate the first radical. So we're going to isolate that radical, get it by itself, and now we have to square both sides. So the left side, that square root's going to cancel, and we'll have k minus 5. On the right side, be careful that you don't think this is equal to the square root of k squared plus 1 squared. It is not. It's equal to the square root of k plus 1 times the square root of k plus 1. And you have to multiply that out. So k minus 5 is equal to square root of k times square root of k is k. Square root of k times 1 is the square root of k. The square root of k times 1 is the square root of k. And 1 times 1 is 1. So we got rid of the first square root. Now we're going to have to get rid of the second square root. And we're going to have to isolate that second square root, get it by itself on one side of the equation, and then we'll be able to square both sides. So the first thing we can do here is get rid of these k's. They cancel out. And then we'll subtract 1 on both sides, and we'll have negative 6 is equal to 2 square root of k. Now I need to divide both sides by 2 so I can get that square root of k completely by itself. So I'll have negative 3 is equal to the square root of k. And now I'm going to square both sides again. So I'm going to have 9 is equal to k. And now I have to check it and make sure it actually works in this equation. So square root of k minus 5, so that's 9 minus 5, minus the square root of k, which is 9, plus 1 equals 0. So the square root of 9 minus 5 is square root of 4, minus square root of 9 plus 1 is supposed to equal 0, so 2 minus 3 plus 1 equals 0, and that's true. So it does work, and so 9 is the solution of this equation. As I said in the previous slide, we can raise both sides of an equation to the same power, and the solutions of the new equation will include the solutions of the original equation. So say you have the solutions, you have some equation, the solutions of the original equation might be A, B, and C, whatever they are. The solutions of the equation you get after squaring both sides might be A, B, C, D, E. So even though it does include the solutions to the original equation, it also may include other solutions that are not actually solutions to the first equation. That's why you have to check, because sometimes you get one of those extra solutions that actually does not work in the original equation, because when you square both sides or cube both sides, you are adding solutions. So let's do this one just like we did the other one. We're going to isolate the first radical. So we're going to subtract the square root of x on both sides. So we'll have 2 minus the square root of x on the right. And now we need to square both sides. The square root will cancel out, and we'll have x minus 8 is equal to 2 minus the square root of x times 2 minus the square root of x. We have to multiply that out. So we're going to have 2 times 2 is 4 minus 2 square root of x minus 2 square root of x plus square root of x times square root of x is x. So got x minus 8 over here. We can go ahead and cancel those x's. And now we need to isolate the square root of x. So I'll subtract 4 on both sides. And we'll have negative 12 is equal to negative 4 times the square root of x. Going to divide both sides by negative 4. And I'll have 3 is equal to the square root of x. That means if I square both sides again, that 9 is equal to x. Now I have to check it. Let's put it back in the original equation. So 9 minus 8 plus the square root of 9 is supposed to equal 2. And this is the square root of 1 plus the square root of 9 equals 2. And that is 1 plus 3 equals 2. And that is not true. No. So the solution is the empty set. You can write that, you can write that, or you could even write no solution. Okay, we're going to talk about forced vectors. And this is when we apply a force to some object. We've talked about this a little bit before. And now we're going to talk about changing a push force to a pull force. Okay, so say we want to lift this elephant by pulling on these ropes. We want to figure out if we pull him in this way with these directions, are we going to be able to get him where he's supposed to go? So all we need to do is change these vectors to rectangular coordinates so that we can add the x's and add the y's. So we've got a 30-degree angle here, and it's being pulled with a force of 40. The hypotenuse of the triangle is 40. And so we need to find x and y. The sine of 30 degrees is going to be y over 40. That's opposite over hypotenuse. And so 40 times the sine of 30 degrees is equal to y. And if you have learned your 30, 60, 90 triangle, you know that sine 30 is 1/2. And so that is 20. So the y coordinate for this force right here is 20. I'm just going to go ahead and put that where the y coordinate goes. And then cosine 30 is adjacent over hypotenuse, so x over 40. And if I multiply both sides by 40, I'm going to have 40 cosine 30 degrees is going to be x. And so if you know your 30, 60, 90 triangle, you know that the cosine of 30 degrees is the square root of 3 over 2, and that is going to be 20 times the square root of 3. So I'm going to put that for my x. The second one is 45-degree angle with a force of 70. Sine 45 degrees is going to be y over 70, opposite over hypotenuse. So I'm going to multiply both sides by 70, and I'll have sine 45. That's going to be y. And now you can plug this into your calculator. I happen to know that sine 45 is the square root of 2 over 2. And so this is going to be 35 times the square root of 2 for my y. So I'm going to put that over here. This is in the second quadrant, and y is positive in the second quadrant because you go up. So y is positive, and I'm just going to go ahead and put that right here. 35 times the square root of 2. All right, so cosine 45 is going to be x over the hypotenuse, adjacent over hypotenuse. Multiply both sides by 70, 35 square root of 2 again. So that is our x coordinate. And remember, in the second quadrant, x is negative because you're going to the left. So this is going to be negative 35 square root of 2. And since you have probably changed these to decimals, I'll just go ahead and do that too. So if we do that, we're going to get negative 14.86 and 69.50. Okay, so we want to change these coordinates back to polar coordinates because when you find a resultant force, you want the direction, you want the magnitude, so you've got to change it back to polars. So we're going to take this point and we're going to graph it and find out what our angle and what our radius is. So this is negative 14.86, positive 69.5. So that's going to be in the second quadrant where x is negative and y is positive. Then we've got our angle, we're going to call it theta. We need to find out what that is. And then we've got our x and y. We know x is 14.86 negative and y is 69.50. So now we're going to use tangent to find out what theta is, and we can use the Pythagorean theorem to find out the value of the hypotenuse, which we will call r. So we'll use the Pythagorean theorem first. So 69.50 squared plus 14.86 squared is equal to r squared. And if you punch that into your calculator, you had 69.5 x squared plus 14.86 squared equals, and take the square root, and you're going to get that r is about 71.07. All right, now I'm going to find theta by using tangent. Tangent of theta is equal to opposite over adjacent. So opposite is 69.50. Adjacent is 14.86. And I'm going to punch that into my calculator. 69.5 divided by 14.86. Hit equals. And now I'm going to hit inverse tangent. And that's going to give me about 77. This is theta, about 77.93 degrees. So that is theta degrees. All right, but that is not the angle I want for my answer. This is the angle I want. So I am going to subtract from 180 77.93. And I get 102.07 degrees. So my final answer after all that work is going to be 71.07. That's the length of that vector, the magnitude of that vector. And then the angle is 102.07 degrees. And your book would write this in this way. Okay, here's another one. This one is where we have a push that we're going to change to a pull. Anytime we have a push, we are going to change it to a pull because it's the same force. It has the same effect on the object. So here a point is acted on by a push and a pull. We will redraw the push as a pull from the other side. So you have this push with a force of 10, and it's just pointing straight to the right. And then you have this other force that's pulling up at a 30-degree angle with a force of 16. To add these two together, we're going to need to change that push to a pull. So now we have these two vectors right here, and we're going to add them together. Now, one of them is super easy. This is pointing straight to the right, and if you think about it, if you think about this as a point, well, this point is on the x-axis. And so the point that is 10 to the right on the x-axis is just the point 10, 0. So that's this point, 10, 0, this vector. All right, and now we have to change the one that is at 30 degrees with the 16. We have to change that to rectangulars to find x and y for that one. So sine 30 degrees is equal to opposite, which is y, over hypotenuse, which is 16. So 16 sine 30 degrees is equal to y. We know that sine 30 is 1/2, and so that's 8. So our y coordinate is going to be 8. Our x coordinate we get by cosine 30 is equal to adjacent, which is x, over hypotenuse, which is 16. Multiply both sides by 16 to find x. If you punch that into your calculator, you're going to hit 16 times 30 cosine equals about 13.86 about for x, and that's going to go right here, 13.86. So I'm going to add those two things together. If I do that, I'm going to have 23.86 for my x and 8 for my y. So now I need to change this back to polar coordinates. So I'm going to think about it. It's got both a positive x and a positive y. That is in the first quadrant. So my x is 23.86 and my y is 8. I need to find theta and r. Find r, I use the Pythagorean theorem. 8 squared plus 23.86 squared is equal to r squared. Punch it into your calculator. 8 squared is 64 plus 23.86 squared equals, then hit the square root sign, and you get about 25.17 for r. And now I'm going to use tangent to find theta. So tangent theta is equal to opposite, which is 8, over adjacent, which is 23.86. Going to punch that into my calculator. 8 divided by 23.86, hit equals. And now I'm going to take the inverse tangent because I don't know what theta is, so I can't take the tangent of it. So inverse tangent, and that's going to give me that theta is about 18.54 degrees. And I am done. I just need to write my answer. R is 25.17. And then theta, since we're in the first quadrant, I don't have to do anything to it. 18.54 degrees, or the way your book writes it would be 25.17 with this bracket, 18.54 degrees. Okay, we're going to talk about metric volume. We use 3 different kinds of measures most of the time. Length is a one-dimensional measurement. It's just one dimension, length, that's it. It measures things like distances, heights, depths, circumferences. Anything you would measure with a ruler just one way, that is length. And in imperial units, which we would use inches, feet, miles, yards, that kind of stuff. For metric, they would use millimeters, centimeters, meters, kilometers, and those things. For area is a two-dimensional measurement, and we use it to measure flat surfaces like floors, walls, windows, land. We're trying to figure out how many squares of a certain side will fit on top of that flat surface. And the imperial units, square inches, square miles, acres, lots of different things. Metrics, we have square meters, square kilometers, etc. For volume, that's a three-dimensional unit. We use it to measure liquids, gases, solids, air, water, coffee grounds, medicine, anything that's three-dimensional. In the imperial units, we use cubic inches, cubic feet, gallons, ounces. In metric, they use cubic centimeters, cubic meters, and liters, and many more. So what's the scoop? Notice that in the list of units for volume, there are some, like gallons, ounces, and liters, that do not have the word cubic in front of them because they have special names that already indicate that they're units of volume. However, behind those special names, there is a cubic measure. You'll be excited to know that a gallon is actually 231 cubic inches. Why is that? Nobody knows. An ounce of some kind of matter is exactly 1.8046875 cubic inches. Don't know why. Now, the liter, on the other hand, is exactly 1,000 cubic centimeters, and 1 cubic centimeter is called a milliliter, and a cubic centimeter is the exact amount of water that weighs 1 gram. So you can see that the metric system is a very well-ordered system based on the number 10, and there's no guesswork with it. You know how all the different units fit together. By the way, who uses imperial units? You may know it is America. That's it. Metric units are used by the entire rest of the world. Liberia and Myanmar do use imperial right now, but they are switching to metric. It doesn't look like America is switching to metric much at all. So it's a strange phenomenon that America is the only holdout in using imperial units, which are very difficult to work with, as you may know. 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile. All these numbers that don't really necessarily come right to your mind immediately. So we're going to look at something about metrics, and that is that 1 liter is equal to 1,000 cubic centimeters, which is equal to 1,000 milliliters. So a liter is 1,000 milliliters. Milli is a prefix meaning 1,000. So cubic centimeter is 1 milliliter. A cubic centimeter is like a tiny little cube that's just 1 centimeter on each side, and it would weigh 1 gram if you put that much water on a scale. 1,000 of those is 1 liter. So we're going to have to learn how to change liters to milliliters so we can change to cubic centimeters so we can then change to imperial units. So if we have something in metric volume and we want to change it to imperial unit volume, we're going to have to do it that way. So here's what we would do. So if we want to convert 14,000 milliliters to liters, that's pretty easy. There's 14,000 milliliters is what you're starting with. And you know that 1 liter is 1,000 milliliters. So all you have to do is multiply this by 1 liter in 1,000 milliliters. And so the 3 zeros are going to cancel, and that would just be 14 liters. So simple. Going from metric to metric is just a matter of moving a decimal point left or right. 14,000 milliliters is just 14 liters. Use unit multipliers to convert 4 cubic feet to liters. Okay, this is tricky. First of all, we don't have a conversion that we've memorized for feet to liters, so we've got to go through inches, 2 centimeters, 2 liters. So starting with 4 cubic feet, we're going to get this to inches by saying that there are 12 inches in 1 foot. And we're going to have to do that 3 times to cancel out the cubic feet. So now we are at cubic inches and we need to get to centimeters. We know that there are 2.54 centimeters in 1 inch. And again, we're going to have to cube that to get rid of those cubic inches. Now, we know from up here, there is 1 cubic centimeter in a milliliter. So we want to cancel the cubic centimeters. The cubic centimeters here are in the numerator, so I want the cubic centimeters to be in the denominator. So 1 cubic centimeter, and that is 1 milliliter. So that's going to make those cubic centimeters cancel, and I'm going to be left with milliliters. I don't need to cube this because the cubic centimeters are already cubed in this conversion unit multiplier. So don't cube this. It's already cubed cubic centimeters because milliliters doesn't have a cube on its unit because it already means a unit of volume. So do not cube this. Now I'm at milliliters. I want to get to liters, and I know there are 1,000 milliliters in a liter, so 1 liter in 1,000 milliliters. And so now I would just multiply all that out. It looks like your book is not multiplying that out, so we'll just leave it the way it is. It'll be 4 times 12 cubed times 2.54 cubed all over 1,000. And that's going to be liters. All right, if we want to change 4.7 liters to cubic inches, we're going to have to go through cubic centimeters again. So 4.7 liters, we're going to have to get this to milliliters. There are 1,000 milliliters in 1 liter. So 1,000 milliliters in 1 liter. This is going to cancel the liters. Now I'm at milliliters. There is 1 milliliter in 1 cubic centimeter. That's what a milliliter is. It's a cubic centimeter. So 1 cubic centimeter is the same thing as 1 milliliter. That will cancel the milliliters. So I've got cubic centimeters. I need to get to cubic inches. There are 2.54 centimeters in 1 inch. And I have to cube that because this is cubic centimeters. So I need cubic centimeters to make it cancel out. And that will leave me, the liters are gone, the milliliters are gone, the cubic centimeters are gone, and I'm just left with cubic inches. So it's 4.7 times 1,000 all over 2.54 cubed. The 2.54 is cubed because I had to cube that to get rid of the cubic centimeters. Okay, going back to remember our 30, 60, 90 triangle will always have the ratios. Short leg to hypotenuse is 1 to 2. Short leg to long leg is 1 to the square root of 3. And so we can always find any missing parts for that triangle if we know one of the parts, especially if we know the short leg. It's very easy. The short leg is 3 in this triangle. We know it's the short leg because it's across from the smaller angle, the 30-degree angle. We know that to get the hypotenuse, if we know the short leg, we just multiply by 2. So y equals 3 times 2, which is 6. And we know that to get the long leg, if I know what the short leg is, I just multiply by the square root of 3. Make sure you know that. Make sure you have it memorized or that you can figure it out, which you can do if you draw a 30, 60, 90 triangle. We did that in a previous lesson. You can go back and take a look at that. All right, so we call a right isosceles triangle a 45, 45, 90 triangle. We've done a couple of problems that have shown us the pattern that you find with a 45, 45, 90 triangle or a isosceles right triangle. So we know if the two legs are equal, then we can use the Pythagorean theorem to find the hypotenuse. And we can see that the hypotenuse is square root of 2, but we'll show why that is. 1 squared plus 1 squared is equal to x squared, the hypotenuse. So 2 is equal to the hypotenuse squared, so x is the square root of 2. So the relationship for a 45, 45, 90 right triangle is always 1 to 1 for the legs and 1 over the square root of 2 for the hypotenuse. So if you have a leg and you want to get the hypotenuse, you just multiply the leg by square root of 2. If you have the hypotenuse, like you do over here, you're going to have to divide by the square root of 2 to figure out what the legs are. So 7 divided by the square root of 2 is going to be x, or y, because x and y are the same. So we would multiply that by the square root of 2 over the square root of 2 to rationalize it. So in that triangle, x and y are both 7 square root of 2 over 2. So if you have a leg, you multiply by the square root of 2 to get the hypotenuse. If you have the hypotenuse, you divide by the square root of 2 to get the measurement of either one of the legs in an isosceles right triangle.